On a quiet summer evening, a Boeing 767 is cruising at 41,000 foot over central Canada, carrying 61 passengers across the country. Everything seems normal until the pilots are suddenly faced with a series of low fuel pressure warnings. One by one, the engines fail, cutting power to the aircraft and plunging the state-of-the-art flight deck into darkness. The captain declares a mayday and decides to divert to a nearby airstrip in Gimli, unaware that the runway has been decommissioned and turned into a drag racing track. On the ground, families are enjoying a sunny afternoon at the strip where children race their bikes along the old runway and barbecues are in full swing for a weekend family day. None of them know that a Boeing is silently descending toward them, and neither do the pilots who believe they're aiming for an empty runway. Can the crew prevent a tragedy? This is the story of Air Canada Flight 143. On July 23, 1983, around 7 p.m., an Air Canada Boeing 767 pushed back from the gate in Ottawa, beginning its cross-country flight to Edmonton, Alberta. The aircraft was carrying 61 passengers, 2 pilots, and 6 flight attendants. In command of Flight 143 was Captain Robert Pearson, a senior pilot with 26 years of experience and over 15,000 hours of total flight time. His prior experience included flying Douglas DC-3, DC-8, and DC-9, Vickers Viscount, and Boeing 727 aircraft. Beside him sat First Officer Maurice Quintal, a Canadian Air Force graduate with over 7,000 hours of total flight time. Air Canada had just introduced the Boeing 767 to its fleet, and the 4-month-old aircraft Pearson and Quintal were taking was one of the only 4 767s in the fleet. It was different from other Air Canada aircraft in many aspects, which we will discuss later. With the engines running and the passengers seated, Flight 143 began its taxi to the departure runway. Ottawa is a relatively small airport, especially for a wide-body giant like the 767, and the aircraft lined up on the runway only a few minutes later. After takeoff, Flight 143 turned northwest and began its climb to cruise altitude. The forecast was showing good weather along the way with no significant deviations. The route to Edmonton would take Flight 143 over northern Ontario, Manitoba, and Saskatchewan before it would finally reach Alberta. Enjoying a strong tailwind at 41,000 foot somewhere near the Ontario-Manitoba border, Captain Pearson turned to First Officer Quintal and gleefully remarked that for once, everything was working properly. He had clearly jinxed it as only a few minutes later, an aircraft warning notified the crew that the left fuel pump pressure was too low, meaning that the engine was not receiving the fuel at an adequate rate. Unsure of what the problem was, but not willing to take on unnecessary risks, Captain Pearson decided to divert and land at the nearest airport. Flying over central Canada, his closest suitable option was Winnipeg, Manitoba, an airport approximately 120 miles south of their location. The crew advised air traffic control of their decision and began the descent. A few minutes later, the right fuel pump was losing pressure as well. Puzzled, the flight crew declared an emergency with air traffic control and began running through checklists, hoping to identify the problem. Having just finished dinner, one of the passengers noticed something strange. She couldn't quite figure it out until a sudden realization hit her. The plane had gotten too quiet. With no adequate fuel supply, the left engine began losing power until it shut down entirely. Soon thereafter, the right engine followed. Suddenly, at 35,000 feet above the ground and still 65 miles from Winnipeg, Captain Pearson found himself in control of a 150-ton metal glider with 69 souls on board. "Oh," were the only words that came out of his mouth at that moment. He now had to do the unthinkable, land a 150-ton aircraft with no engines. That takes training, focus, and nerves of steel. Thankfully, not everything in life is that complicated, like building your own website. With ODU, the sponsor of this video, it's as easy as picking a theme, dragging a few blocks, and you're off the ground. No checklist required. If you've ever tried to build a website and ended up drowning in plugins, updates, or clunky templates, there's a much easier way. ODU is an all-in-one management software with apps for everything for your business, from accounting and inventory to email marketing and yes, website creation, and much more. In just 4 steps, you've got a fully functional site. Define the type, your industry, and your goal. Pick your colors or add your logo, add pages and features, choose a theme. Done. Then just drag and drop blocks to bring it to life. No coding, no headaches, just clean, customizable blocks for everything. Text, colors, images, layout, and animations. Out of ideas? Odoo's built-in AI can help you write, rephrase, or translate your content in seconds. Best of all, it's free to start. The first app is free for life, including unlimited hosting and support, and you get a custom domain for a full year. So, if you're ready to build something great without the complexity, check out Odoo and try the website app for free today. The horror of Flight 143 resulted from a chain of events that began in Edmonton, Alberta, one day before the flight. During a routine maintenance inspection of the 767, an aircraft technician noticed that a faulty fuel quantity information system processor, or FQIS, caused the fuel gauges inside the flight deck to go blank. The fuel gauges, located at the top of the overhead panel, are operated by two FQIS channels. Although if one channel is deactivated by pulling a circuit breaker, the other one can take over. Pulling the circuit breaker for one of the channels, the technician reactivated the fuel gauges. He could not replace the processor right away as there was no replacement available. To avoid a lengthy delay or a potential cancellation of the flight, the technician deferred the FQIS in accordance with the aircraft's minimum equipment list and made a corresponding logbook entry. Due to the extreme redundancy of aircraft designs, some less critical systems are allowed to be inoperative for a limited amount of time until a repair is made. These systems are listed in a minimum equipment list, or MEL. Generally speaking, if a system is not listed in the MEL, for example, an engine or landing gear, then it has to be in working condition before each flight. To ensure safe operations and avoid compromising safety, MEL items may include provisions or restrictions and may require additional actions to be performed by either the flight crew or maintenance. Air Canada's Boeing 767 MEL allowed one fuel processor channel to be inoperative as long as maintenance performs a drip check before every departure to verify the fuel quantity on board. The drip check was to be completed with the measuring sticks installed inside each fuel tank. During the drip check, a drip stick installed inside each fuel tank was pulled out to measure the fuel level. The measurement showed the depth in centimeters of the fuel inside the tank. Using corresponding reference tables from Boeing, this value would then be converted into volume in liters or gallons. And because aircraft fuel gauges measure fuel in weight rather than volume, the last step was converting volume to weight using a specific coefficient called the conversion factor. Once the weight of the fuel on board had been calculated, it was subtracted from the total fuel required by the flight plan. The difference indicated how much fuel still needed to be loaded. Adding another layer of complexity, fuel trucks measure fuel in volume, not weight. So, the calculated fuel amount had to be converted back from weight into volume using the same conversion factor. A piece of cake, isn't it? To make matters worse, in the early 1980s, Canada was in the middle of a decade-long transition from the imperial system to the metric system. It was a costly ordeal that affected not only aviation but also other transportation sectors and the manufacturing industry, creating widespread confusion and challenges along the way. In compliance with the transition, Air Canada had requested Boeing to equip its newly built 767s with fuel gauges that displayed weight in kilograms instead of pounds. A pound is a much smaller unit, and therefore converting liters to kilograms required a different conversion factor, one that was not widely known among Air Canada personnel. The aircraft flew to Montreal with a stop in Ottawa the day after its maintenance inspection. It landed in Montreal around 4 p.m. local time, where it was serviced again and prepared for its return flight as Air Canada Flight 143, operated by Captain Robert Pearson. Captain Pearson met the arriving crew on his way to the airport terminal and discussed the condition of the aircraft. He was advised to avoid refueling in Ottawa. This was something that would normally be done. Instead, he was told to load enough fuel in Montreal for the entire trip. From this conversation, he mistakenly believed that the aircraft had flown to Montreal with inoperative fuel quantity gauges, which was not the case. In the meantime, a maintenance technician in Montreal arrived at the aircraft to perform the drip check before the return journey to Edmonton. While waiting for the fuel truck, he decided to take initiative and troubleshoot the faulty FQIS. The technician pushed in the circuit breaker for the faulty channel of the processor and ran a diagnostic test. Pushing the circuit breaker activated the faulty channel, turning the fuel gauges blank. Unable to fix the issue, he got distracted by the fuel truck that had just parked near the aircraft and forgot to pull the circuit breaker after he was done. As a result, although the fuel gauges had been working on the inbound flight to Montreal, they were blank once again, meeting Captain Pearson's expectations about the state of the aircraft. Although Captain Pearson questioned the legality of flying without working fuel gauges, he was reassured by a maintenance worker that Air Canada's Maintenance Control Department approved it. That was not true, and no approval had been granted as bypassing the MEL was not authorized. Thinking that the aircraft had already flown in this condition, the captain did not argue further. Captain Pearson and First Officer Quintal met with the maintenance worker and the fueler at the aircraft. According to the flight plan, the aircraft would need at least 22,300 kilograms of fuel. This included the fuel to get to Edmonton as well as the additional fuel reserve and diversion fuel legally required to be on board for the flight. The drip check showed that the aircraft had approximately 7,700 L on board. Because of the gap in company policies, the responsibility for making fuel calculations was not clearly defined and delegated. As a result, neither the flight crew nor aircraft maintenance were trained to perform these calculations, and as such they had no knowledge of what conversion factor to use. After a brief conversation, the flight crew, the maintenance technician, and the fueler agreed to use the conversion factor used for other aircraft at Air Canada, making a crucial calculation mistake. Remember, because the 767 measured fuel in kilograms, it required a different conversion factor. Multiplying 7,700 L by 1.77, the conversion factor for pounds, the crew assumed they had 13,600 kilograms of fuel on board. Then they subtracted this number from the required 22,300 kilograms and determined they needed 8,700 kilograms of fuel to be loaded. Dividing the number by 1.77 yielded 4,900 L, which was the fuel that was eventually transferred onto the aircraft. Had the crew used the correct conversion factor of 0.8 to convert liters into kilograms, they would have calculated that there was only 6,200 kilograms of fuel on board. Subtracting it from the required 22,300 kilograms would show that the plane needed an additional 16,100 kilograms or 20,000 L of fuel. By adding only 8,700 kilograms of fuel to the aircraft, the crew of Flight 143 left Montreal with exactly half of the total fuel they needed for the flight. This, however, was enough fuel for the 40-minute hop to Ottawa, and no issues occurred on the quick flight. As the aircraft landed in Ottawa, company maintenance workers once again met the aircraft to complete the drip check procedure. Unfortunately, they also used the wrong conversion factor and the same calculation mistake was made. Normally, the aircraft's flight management system receives the information about fuel on board from the FQIS, calculating the aircraft's maximum range and warning pilots if the planned route exceeds the range. However, because the FQIS was accidentally disabled, Captain Pearson had to manually input current fuel quantity calculated incorrectly into the FMS before every departure, including in Ottawa. Paired with the captain's earlier decision to avoid fueling at the intermediate stop, this sealed the fate of Flight 143. The Boeing 767 departed from Ottawa for a 4-hour journey, carrying only 2 hours' worth of fuel on board. Fast forward a few hours, as the engines on Flight 143 shut down, the generators stopped producing electrical power. As a result, every display in the state-of-the-art flight deck went dark. Thankfully, Boeing had installed a backup measure for the unlikely event of a dual-engine shutdown, the ram air turbine, extending from the bottom of the fuselage. This tiny generator uses ram airflow to produce electricity. Its output is too low to power the entire aircraft, but it has enough juice for the most essential flight instruments: a standby artificial horizon, an altimeter, an airspeed indicator, and a magnetic compass. Without the navigation system and the vertical speed indicator, the pilots were no longer able to estimate how far they were from their diversion airport and how fast they were descending, information crucial to the success of their approach. The aircraft's transponder, which supplies ATC with the aircraft's position and altitude, had also failed due to the lack of power supply. Luckily, the controllers in Winnipeg still had access to the primary radar. Its limited functionality only showed Flight 143 as an unknown target on the screen. Using a standard ruler laid against the radar screen and interpolating the distance, ATC gave the crew updates on their position every few minutes. Continuously evaluating how much altitude they had lost while traveling over a certain distance, First Officer Quintal calculated the aircraft's rate of descent. As the aircraft reached the 30 miles mark from Winnipeg with the airport in clear view ahead, it looked like things were turning for the better. However, after doing another calculation of their descent profile, the first officer reached a worrying conclusion. At 8,500 feet above the ground, the aircraft was 30 miles from Winnipeg, but could only glide for another 20 miles, 10 miles too short to make it to the runway. After a quick discussion with air traffic control, the crew agreed on a suitable alternative. Just 12 miles to their right and north of Winnipeg was a former Air Force base with a runway long enough for the 767. It was located near a small town of Gimli, Manitoba. However, the paper chart supplements the crew carried with them did not have any information about the Gimli airport. With the sun slowly reaching the horizon, the pilots would be flying at dusk to an airport they had never landed an airliner at, experiencing an emergency situation they had never trained for. Luckily, it was a familiar airfield to First Officer Quintal, who had been stationed there during his military service. There was only one problem with Gimli that neither the crew nor Winnipeg air traffic controllers knew about. Runway 32 left, the runway that Captain Pearson chose to land on, had been decommissioned and turned into a racetrack with a drag strip and various racing courses. And on the evening of July 23, 1983, the Winnipeg Sports Car Club was hosting a family day, inviting hundreds of people to come to Gimli for a weekend of racing, go-karting, and barbecuing. Many spectators brought their children and set up camping tents along the runway. Turning the aircraft toward Gimli, the crew began final preparations for the emergency landing. In a matter of seconds, Captain Pearson's problem shifted drastically from being too far and too low to being too close to the runway and still too high. Although the ram air turbine was powering the hydraulic system, the pressure in the system was not high enough to operate wing flaps and speed brakes, which could generate additional drag and slow down the aircraft. Neither was it sufficient to extend the landing gear. Hence, the pilots had to resort to the manual gear extension procedure, releasing the locking mechanism and letting the gear drop under its own weight. Looking at the landing gear indicator, First Officer Quintal saw 2 green lights and 1 red. Although the nose gear extended, it did not lock into the down position and could fold back on impact. The crew had no time for troubleshooting, which meant only one thing. Captain Pearson had to land as smoothly as possible, ensuring that the nose of the aircraft did not drop too fast after touchdown. At the same time, without the flaps, the aircraft would be approaching at a speed much higher than the typical landing speed. Thus, the crew needed the touchdown as close to the runway threshold as possible, leaving enough room to slow down. This landing would have to be extremely smooth, yet very precise. And with no possibility of a go-around, Captain Pearson had only one shot, a challenge to say the least. If they tried to descend at a more shallow angle, allowing the aircraft to lose some airspeed, they would touch down much further from the threshold, reducing the length of the runway available to slow the plane down. By aiming at the threshold and performing a more aggressive descent, the crew risked gaining too much airspeed and once again not being able to slow down in time. Both pilots briefly considered doing a 360 degrees turn to lose altitude, but quickly realized that they were already too low for the maneuver. Running out of options, Captain Pearson considered the unthinkable, a forward slip. It's a very common technique among pilots of gliders and light aircraft, but it's practically unheard of when operating large jetliners because of the additional risks it creates. As a hobbyist glider pilot, Captain Pearson was very familiar with the maneuver, but he had never tried doing it in the 767 or any other airliner. The flight crew would become experimental pilots with 67 souls behind their backs. Yet, this was their best chance at surviving the landing. By crossing the controls, that is, by turning the ailerons in one direction and the rudder in the other, the captain banked hard to the left while keeping the nose of the aircraft level with the horizon and aimed at the runway. Maintaining this sideways position created much more drag and allowed the pilots to descend faster without gaining additional airspeed. The added drag of flying sideways made the plane extremely shaky with the wind howling much louder, sending fear and anxiety through the cabin as they approached the runway in a steep and dangerous descent with the airplane wings at a nearly 90 degrees bank angle. Passengers seated on the right saw nothing but the blue sky. In contrast, those on the left could not just see golfers on a course underneath them but could almost make out what clubs they were using. A pretty surreal sight during what they believed were their final moments. On the ground, however, it was business as usual. With the engine shut down, The 767 was flying toward Gimli in complete silence, and nobody at the racetrack even knew what was happening until they saw the massive airliner heading their way. Approaching the runway, Captain Pearson had another unpleasant discovery. The forward slip significantly slowed down the ram air turbine, which meant that the pressure in the hydraulic system dropped even further. Without adequate pressure in the hydraulic system, the flight controls got heavy and more sluggish. He was able to put the plane into a slip, but can he get out of it? Hoping to slow down as much as he could and his eyes glued to the runway, the captain maintained the forward slip until the last moment. Just before reaching the airport, he yanked the controls hard in the opposite direction, straightening out the aircraft. Flying over the airport fence, the first officer began noticing the racetrack in the distance. Focused on the threshold, the captain didn't see it, and by the time the first officer could react, it was too late. They were already committed to landing on runway 32 left. As Captain Pearson wrestled with the heavy controls of the 767, he touched down just 800 foot past the threshold. Rolling down the runway at 40 knots above the normal landing speed, he slammed on the brakes, locking the wheels. Seconds later, 2 tires blew out, sending loud bangs through the cabin and triggering even more panic. The nose landing gear, which did not lock into position during the manual extension procedure, collapsed under the weight of the aircraft, and the nose hit the surface of the runway, once again, creating extreme noise and terrifying the passengers. In the flight deck, the crew saw some small objects in the middle of the runway about 1,000 feet ahead of them. As they got closer, terror struck Captain Pearson. These objects were 2 teenage boys riding bicycles. Adding to the list of lucky coincidences, the failure of the nose landing gear caused the nose of the aircraft to grind against the surface of the runway, acting as a very powerful brake. Using his rudder pedals, the captain slightly swerved the aircraft to slow down even further. The aircraft, with 69 people on board and 0 fuel, came to rest within less than 1,000 feet of the campground, full of racetrack visitors chaotically running away in different directions. Luckily, the boys and everyone else in the way of the metal giant ran away to a safe distance. Through a combination of luck and skill, the crew of Air Canada Flight 143 managed to avoid any fatalities in the plane and on the ground, and the only injuries associated with the accident were received during the evacuation process. So, who was at fault in the Air Canada Flight 143 accident? Although the investigation board held Captain Pearson accountable for leaving Montreal with broken fuel gauges, the investigation report assigned most of the responsibility to Air Canada as the organization. The board determined that company management neglected to assign clearly and specifically the responsibility for calculating the fuel load in an abnormal situation and failed to reallocate the task of checking fuel load, as this task had previously been delegated to the flight engineer, a role that became obsolete on the Boeing 767 fleet. Although there was another runway in Gimli, runway 32 right, Captain Pearson stated that he was so locked in on his airspeed and the threshold of runway 32 left that he did not even notice the other runway. Furthermore, the crew did not have enough altitude to switch runways once the decision to land on 32 left was made. The aircraft involved in Flight 143 was flown out of Gimli only 2 days after the accident. After further repairs, the 767 continued to fly for Air Canada until its eventual retirement in 2008. Captain Pearson and First Officer Quintal, who had since been promoted to captain, both remained with Air Canada and joined the retirement flight of the Gimli glider as it was flown out to the desert. If you liked this video, please give it a thumbs up and subscribe to the channel for more free tutorials.